Okay, so if you know the base and the height, then we can just use the standard formula for area of a triangle like we talked about up on the board. Okay? Okay, now, here's the part that's different. What do you do? Hey. Okay. What do you do when we do not know the height, but we can use trig to calculate the area? So what happens when you don't know the height? Okay, here, when we knew base and height, no problem. What do we do when we don't know the height? So here's three cases, or two examples where you want to find the area, but you don't know the height. Okay, so how could we figure out what that is? All right, so we got two sides on here that we know, 10 and 8. And what we need to know is what's the height that goes with those sides. Okay, now remember, the height has to be 90 degrees. So what I can do is I can draw a line that either goes to the 10 or to the 8 that's perpendicular to it. All right, so for example, if I called this capital A, called this B, and called this C. All right, if I was going to draw a height to 10, where would it start from? B. All right, so sketch that in. Okay, this is the height that belongs to this 10. So I could find the area of this triangle if I could figure out what that measurement is. All right, so we know the area of a triangle equals 1/2 the base times the height. So 1/2, we know what the base is, but we don't know the height. So we can't put anything in there. If we could, then it would be easy peasy. 5 times whatever we get for the height. Yes?
Now, no matter what height you use, would the answer always be the same?
Yep. As long as you use the correct height, the height that belongs to whatever base you're using.
Does that mean that you could be able to set the equations of two different heights to equal each other?
Correct. Yep. Yep. Because they would have the same area. All right, now what we're going to do is we're going to see, is there a way that we can use right triangle trig to get that height? Okay, so if you took this triangle, okay, if we took that, I'm going to draw it over here to the side. Okay, this is 49. This is 8. Okay, now that's one of our right triangles. So we can use SOHCAHTOA to get H. Okay, so what function would you use? Sine. Because H is the opposite, 8 is the hypotenuse. So I could say the sine of 49 degrees is equal to the opposite leg, which is the height, over the hypotenuse, which is 8. Now, if I solve this for h, I'd multiply both sides by 8, and I'd have 8 sine 49. So that's what's going to go right here. 8 sine 49. 8 sine 49. Okay, so we multiply those two. We got 5, or actually, let's do it this way. Let's multiply all 3. Okay. So I could do 1/2 times 10 times 8. So that's 40. So this really becomes 40 times the sine of 49 degrees, which then you can do on your calculator. Be sure that you're in degrees. Okay. So 40, let's make sure I'm in degrees. Yep. So 40, 40 times sine 49. And there's my area. Okay, so if we went out to 3 sig figs, that would be 30.2 square centimeters. Okay. So the shortcut to doing this is the following. If you look at what we did here, guys, if you looked at this formula right here, you'll notice that these are the two sides, and this is the angle sandwiched between them. These are your two sides that you were given, and that's the angle that's sandwiched in between them. Okay, so that's your formula right here. Okay, if you look at this, if I take the sides A and B right here, notice this is the angle that's sandwiched in between them. That's my area. Or if I knew these two sides, I'd go B 1/2 B times C times the sine of the angle that's in between them. If the problem gave me these two sides, I'd go 1/2 A times C times the sine of the angle sandwiched in between them. Okay, so that's how you find the area when you know two sides and the angle in between. I can now find the area without, when I didn't start knowing the height. Okay, so for example, if we go down to find the area of triangle ABD. Okay, ABD, that's this triangle right here. Okay, we want to find the area of that. Okay, well, if you look at what you know two sides, and you know the angle that's sandwiched in between them. Two sides and an angle sandwiched between them. So what that means is I can use these formulas right here. All you got to remember is two sides. This is always the angle that's sandwiched in between the two sides. Okay? So if I was going to do this, I could simply say, okay, the area equals 1/2 times the two sides that it gave me, 7.1 times 9.2 times the sine of the angle in between them. And there's my area. And then you run that through your calculator. 0.5 times 7.1 times 9.2 times sine 60. that is, whoops, to 3 places, 28, 3. So in order to do this formula, guys, you need the minimum you need are 2 sides and the angle in between them. So I heard somebody say, you know, SAS. 2 sides and the angle sandwiched between them. Okay. Now we'll come back to the next example here in a second. All right. If you look at this other situation, well, what if you don't know any of the angles and you know only the 3 sides? So right now, the way this is, you can't use this formula because you don't know. I need to know one of these angles. Okay, I can't do anything unless I knew that angle, or if I knew that angle, or if I knew that angle. If I knew any one of those, then I could do this. Okay, so we've got to find a way that we can do that, and we will in a day when we do the law of cosines. The law of cosines is going to let us figure out what that angle is. Okay, now there is a way to get the area of this though without using the law of cosines. It's called Heron's theorem. And you can use Heron's theorem when you know 3 sides of a triangle. Okay? All right, and his area of a triangle is equal to this. Square root S, and then this is going to be S minus A, S minus B, S minus C. And the letter S is the semiperimeter. So Heron's theorem is a workaround until we can figure out what those angles are. Once we can get what that angle is, then I could use this. All right, so Heron's theorem is real simple, guys. S is, you take the perimeter and you cut it in half. So it's just 8 plus 10 plus 9 divided by 2. Okay, so what is that? 18 and 9, 27 over 2. So that's 13.5. So the area is going to be, okay, 13.5 times all right, take 13.5, take away 10, that's 3.5. 13.5 take away 10, okay, 13.5 take away 9, 4.5. 13.5 take away 8, 5.5. Multiply that out, take the square root, and that's your area. And now I'm going to take the square root of that. And to 3 places, 34.2. Okay. So if you don't know the angle and you know 3 sides, here's a way to get the area of a triangle. If you know just 3 sides and you don't know anything about the angles. Later on in this unit, we're going to learn how to figure out what that angle is. Okay. All right. So we've got this when we know 2 sides and an angle in between them. And we've got this formula when you know 3 sides. All right, now let's go over to this other example here. All right, the area of BCD. Okay, so here's BCD in blue. All right, it tells you what the area is. Find 2 possible measures of the included angle DBC. So DBC, okay, that's this angle right here. Oops, I can't really see that, can you? So you know 2 sides. What are the possible angles that this could be? All right, so if we take our formula, area equals 1/2, all right, the product of the 2 sides, so we got 7.1 and 3.2 times the sine of this angle. So I'm going to call this angle B in the blue triangle. Okay, now we'll fill in our area. 5.69. Okay, let's do this. So 1/2 times those. That's 1136. Sine B. Okay, now how do we isolate the sine of B? Yep. So we're going to divide that side by 1136, that side by 1136, and I get, let's see, 5.69 divided by 1136. Get that long decimal, and I'm going to just leave that in my calculator. But we approximately get, if I went out to 3 sig figs, 501 equals the sine of B. Okay. All right, now we want to find what angle has that sine. So do you remember how to do that on your calculator? No? All right, real quick. Let me show you something.